everyone, we're going to write this trig expression as an algebraic expression containing u and v. So we'll get started with our inner part right here and figure out this. This has the form of alpha plus beta. So we're going to be using this formula here once we figure out this. So basically, let's set alpha equal inverse cosine of u. That means cosine of alpha equals u. And then for our beta, we have beta equals inverse sine of v. That means sine of beta equals v. Now, to use our formula, we also need cosine of beta and sine of alpha. To do that, we're just going to use our Pythagorean identities here. Sine squared plus cosine squared equals 1. And also recall that for our restrictions, this is restricted from 0 to pi, and sine is restricted to negative pi divided by 2 to pi divided by 2. All right, so to find sine of alpha, that's like 1, if this was squared, it's 1 minus cosine squared of alpha. But we only want sine, so take the square root of both sides, and you just get this, which equals square root of 1 minus, now cosine of alpha is u, so that's going to be minus u squared. All right, and then for cosine of beta that we're missing, this would be square root of 1 minus sine squared of beta. Remember, this is just the Pythagorean identity, and you take the square root of both sides. So this is going to be square root of 1 minus v squared. So now we have our sine of alpha, cosine of beta, and cosine of alpha and sine of beta. So now we can use our formula. And our formula that we're going to use is cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. So I'm going to just substitute in my values that we have, and we'll have our answer. So cosine of alpha is u. Cosine of beta is square root of 1 minus v squared minus sine of alpha was v, and cosine alpha was, where are we? Cosine. And sine of beta was 1 minus u squared. So we wrote an algebraic expression containing u and v. And that's it. Thank you. Have a nice day. Bye-bye.